Yeah, thank you. So the Indian Ocean tsunami, it was one of the great natural disasters in human history. Certainly it was one of the greatest natural disasters in our lifetime. The event started with a 9.1 scale earthquake with its epicentre up in northern Sumatra. It produced a tsunami that affected practically every country in the Indian Ocean, and I think the final death toll was about 220,000. Now, I've been travelling to Aceh, which is a small province on the northern tip of Sumatra, for about 20 years. I've been working there since about 2000. I've been following coral reproductive patterns, which is what took me to Indonesia to work. In 2003, I was in Aceh, and in addition to surveying the Apr assemblage to look at reproductive patterns, I just happened to throw down some line intercept transects to record the community composition of corals. So when the tsunami hit, I realised I was in the position to be able to document the changes to the coral assemblages in that area, which is not an area where many people work. It's been a site of civil war on and off for the last 10 or 20 years. It's very isolated. There are not that many marine ecologists in Indonesia. This was very close to the epicentre, so it was a good opportunity to see exactly what effect tsunamis had on coral reefs. Okay, so my talk will be in 3 parts today. And firstly, I will present the ecological story. I'll just quickly run you through some slides to show you what happened in the marine environment. Then I'll briefly show you, again, some more qualitative images, in effect, to demonstrate what impact the tsunami had on the human environment. And then finally, I'm going to run through a bit of data looking at whether or not natural barriers provided an effective barrier to the tsunami. So I think one of the most prominent ideas that came out following the tsunami was that healthy ecosystems did provide some meaningful protection, and the data I'm going to show you today certainly challenges that idea. So again, just quickly, the study areas, so in March 2005, about 3 months after the tsunami, I teamed up with WCS and we did some rapid ecological surveys of the reef. In Aceh, the epicentre of the tsunami was about 100 kilometres to the south. And so what this graph shows, it compares the community structure at 3 sites that I had surveyed in 2003, which is in black, to 2005. Along this bottom axis, there's 10 taxa of scleractinian corals. This is their percent cover. You can see that in the 2 years between the surveys, some have gone up, some have stayed the same, some have gone down. This is just the normal sort of pattern that you'd expect in 2 years change in a coral community. In effect, in the shallow water coral community, the tsunami had absolutely no impact. The waves at this point were about 5 metres, which was rather surprising. This is a photo of the sea gardens at Rubiah in 2003. And there's that same community in 2005, 3 months after the tsunami. So you can see that there's very little impact at all. What you can see here is a fishing net, and that'll become relevant in the next couple of slides. Now, there were areas where the damage was quite spectacular. And so here we have about a 4 metre diameter Porites bommy washed up onto the shore. And so the damage we did see was habitat specific. Corals that were firmly attached to the substratum stayed there. Other corals, like Porites bommies, which typically are just embedded in the sand rather than attached, were excavated and carried onto the mainland, often a long way, as this next slide shows. Some of these things have been transported 50 to 80 metres inland. These bommies are all about 2 or 3 metres across. So while the typical pattern in the shallow water communities was for no damage, and indeed we picked up very little direct damage from the tsunami, what we did see areas where coral cover was very, very low. And so what this graph shows is percent coral cover at 15 sites. And you can see, and I've coloured the sites according to the management regime that was in evidence at the time when the tsunami hit. So the black bars are in an area where there is a traditional form of marine management called Punglim and Laut, which the Archenese have been practicing for many centuries. And you can see that here it has been very effective. The coral cover in these areas is quite high, over 60% in each case. There is also a couple of our sites are in the marine reserve, and again, you can see that the marine reserve has been very effective, at least in protecting coral cover. But in the open access areas, where for whatever reason the traditional system broke down, you can see the coral cover was very low. And so, now, this is the type of reef that we were seeing in these areas of low coral cover. It was very clear that these reefs have been dead for months, or for many months or years, and so we're very confident that this sort of damage was not caused by the tsunami. So this is a colony of a blue coral. Typically when you break it, you can see the blue pigment in its skeleton. That pigment will stay blue for months, even years, and so I suspect this sort of colony has been dead for many years. And from what locals were telling us, the most likely cause of this mortality has been destructive fishing practices, such as bombing, cyanide fishing, the sort of typical problems that you have in many parts of Southeast Asia and Asia. So, just to summarise our conclusions as to the impact we saw in the marine environment, the shallow corals were largely unaffected, and the coral damage was trivial when compared to the effects of destructive fishing practices. And the conclusions that we came to was that, in particular, the conservation priorities have not been changed by the tsunami. The damage that the tsunami directly caused to the reefs was minimal. There's no need for reef rehabilitation, which has been one of the initial reactions of people to come in and start breaking off nubbins and trying to propagate reef. Again, the important thing is to focus on the perennial problems of marine resource management, improving water quality, reducing fishing pressure, and sustainable coastal development. Now, the impact in the human environment was quite fundamentally different, and this is just a list of the municipalities in Aceh, and it tallies the casualties. In some municipalities, 20% of the people died. In some of the villages where we were working, maybe 80% of the people died. I'm going to show you a few images now. Most of you will have seen these spectacular satellite images of the extent of damage. Now, this is a satellite image of two villages, Lampuk and Lokna. This reef is one of the largest reefs in Aceh. In fact, I think it's the longest and the widest. The reason I went there 20 years ago is that there's a very nice right-hander down here and a beautiful left here. So I've had many, many hours of fun at these reefs. This is the same area in January 2005, so this is about a week after the tsunami. The only structure standing was this mosque, and every home in both these villages was destroyed. And these are a few shots from the village itself. The upper shot is a view looking west from the bridge in the village of Lokna. This second shot is taken in March 2005. There's the bridge I was standing on, and as you can see, the vegetation and the homes on the side of the river have just been completely washed away. This is Yusnita and Norma waiting to take me to the airport. That's why Yusnita's dressed up so nicely. Have a look at this, and there's the house again in March. There's the steps that Yusnita and Norma were standing on. So you can see that the destruction in these villages was complete. This is the fish market in November 2000. This is the fish market in April 2005. A rice paddy outside of Lokna in November 2000, and there's the same rice paddy strewn with the debris from the tsunami. So, so the human environment was very badly affected. But and very shortly after, I think in January 2005, the United Nations Environment Programme commissioned a report called After the Tsunami, and they collected a lot of anecdotal evidence. Obviously, it was within weeks. They hadn't had time to quantify it. And what I call the mitigation hypothesis had its genesis in this document. And this is a quote from Klaus Topfler, the Executive Director of the United Nations Environment Programme, saying that anecdotal evidence and satellite photography corroborate claims that reefs and forests and other coastal vegetation provided protection. Now that didn't gel with what I'd seen. Where we were in Aceh, the destruction was complete whether or not there'd been forest or reef in particular. Even Bill Clinton was involved in perpetuating this hypothesis. Here is a quote from Bill as the Special Envoy for Tsunami Reconstruction, saying that we know that if mangrove trees had not been torn down where they previously stood, the losses would have been substantially smaller. Now, this is obviously a beautiful idea. It would be wonderful if trees did save lives. But yeah, is it true? The idea got a lot of legs with this paper that was published in Science. I'm not sure, I think it was about March in 2005 by a guy called Finn Danielson and his team. They used a GIS technology to compare the amount of damage in areas with a lot of forest and in areas with not so much forest. And they came to the conclusions that mangroves and casuarina plantations had attenuated the tsunami waves and provided some protection for coastal villages. There are a number of flaws with that paper, which Alex Kerr and I pointed out in a technical comment to Science, which wasn't published. But very shortly after that, we had the chance to test it with some other data from another study by some Indian scientists, and the data was published in Estuarine and Coastal Shelf Science. Now, the first map is from the Danielson paper, so this is their study area, and you can see this river here is this river here, so there's almost 100% overlap between the two studies in terms of the space that their study sites, the space that they were looking at. The Indian team provided all their data. They did a couple of regressions. They did a couple of regressions of the per capita death rates per village. They plotted it against three variables in particular: area of forest, height above sea level of the individual hamlets, and the distance from the shore. And they found that in all those cases, there was a significantly lower deaths higher, further from shore, and where there was forest. And the conclusions they came to, again, was that coastal mangrove forests had mitigated the tsunami damage. But Alex and I had a look at this data, and we thought that there was more to it than just this simple story. And so we threw all the variables in together into a stepwise regression. And what we showed was that once you've accounted for distance from sea and elevation above sea level, which together explain 86% of the variation in deaths per village. Once you've used those two variables, adding vegetation area doesn't add any explanatory power at all. So again, they've picked up a classic spurious correlation. Once you take account of the distance from shore and the height above sea level, coastal forest made no difference to the number of deaths per village. Now, we weren't satisfied with that. We thought we can do this ourselves with data that we've collected from Aceh. And so here, again, I'm going to present you some data that we collected from GIS. We got a GIS person on board, some satellite images, and we wanted to test, and also we wanted to include reefs in our analysis as well. And so we chose 30 sites, some with reefs, some without. For each of these sites, we had area on coral cover, so we could test whether reef quality affected inundation distance, which was the independent variable we used. So we got a whole heap of variables that we could get from the satellite image: reef length, reef width, wave height at the coast. And again, the variable that my qualitative observations had led me to think would be the most important variable in explaining inundation distance, and that was topography. Now, this is the scar that the tsunami created. This is on the northern tip of Aceh. It's probably about 20 to 30 metres above sea level here. And wherever we went, we were confronted by this scar. In some islands, it was maybe only the 5-metre contour, some the 10-metre contour, some the 30-metre contour. And the run-up has been recorded as high as 50 metres. And so wherever we went, there was this uniform scar along the horizon. And so it made me think that, it was hugging the contour. And so this seemed to me to be the most likely explanation of how far the wave penetrated. And there it is again, quite uniform. There are areas here that were grassed, which you can't see the scar. But everywhere we went, it was incredibly uniform, though it varied in height between locations. So we got the topographic maps. We measured the slope. We measured the slope to 10, 20, 30 and 40 metres as variables to put into our stepwise regression. Tsunami inundation and many features of tsunami are known to be controlled by bathymetry. So we went to all of our sites and we got a lot of bathymetric variables. And also from the satellite, we estimated pre-forest cover. And finally, inundation distance, which was our independent variable. So what we're trying to do is explain inundation distance as a function of all these other variables. In particular, the ones we were trying to test were forest, vegetation, and presence or absence of coral reefs and other coral reef variables such as condition. Now, this is the results of the analysis, and again, very similar to the previous analysis. Two variables were very important in explaining inundation distance. Those two variables were wave height at the coast and the topographic slope. And the slope to 20 metres was the one that explained the inundation distance most effectively. Between those two variables, they explain nearly 73% of the variation, and adding all these other features, and we've added many of them, doesn't increase the explanatory power of it in a significant way. So the best model to explain inundation distance is wave height at the coast plus topographic slope. And again, from this, that we conclude quite strongly, I think, that neither coastal forest nor coral reefs reduced the inundation distance in Aceh. Again, I'll just finish off with a couple of more slides, more images. This, as I said earlier, is the largest reef in Aceh, and certainly it didn't provide any protection for these villages. This is a view of Lochner looking west. This is the Lochner River, beautiful coastal forest, casuarinas, coconuts, plantations. This is that same view after the tsunami. This is Gregory and Peter enjoying the sunset after a hard day at the office. But the most important thing here is the sand dune system, which is about 5 or 6 metre high sand dunes. Keep an eye on that mountain in the background, completely washed away. So, we did not see any features of the coast that mitigated the damage. The natural barriers in Aceh provided absolutely no protection for the tsunami. Again, so this is a view looking west over the villages, looking south over the villages, and that's what it looked like. So all that vegetation has been just stripped away. And we get to write that data up, but Alex and I did a brief opinion piece in Bioscience and reviewed a number of the other papers that have been published, most of them claiming an effect, and all of them flawed. And so in conclusion, there really is not any quantitative support for shoreline vegetation or reefs moderating the 2004 tsunami. And we went on to say that any role of the hypothesis in environmental advocacy and forming policy is misguided and potentially disastrous. Now, why disastrous? Well, they won't work. They create a false sense of security. I don't think anyone would be silly enough to stand behind a mangrove barrier with a tsunami coming, but you never know. Lots and lots of money is being thrown at this problem. This Mangroves for the Future that Bill Clinton officially opened earlier this year is an $80 million program to replant mangroves throughout Southeast Asia. Now, there are many good reasons for replanting mangroves, but if you're serious about saving lives in future tsunamis, every dollar will be wasted. And finally, which I think I've got time to go into, there's a major potential for social injustice. Now, one of the other methods that people are using to save people from future tsunamis is buffer zones. And in particular in Sri Lanka, they've instituted a buffer zone of 100 to 200 metres. In the initial plans for reconstruction in Aceh, they'd actually postulated a 2-kilometre buffer zone. And they were going to fill that buffer zone with palm plantations. So there are a lot of people that stood to benefit from instituting some of these policies. And that's exactly what's happened in Sri Lanka. The reconstruction process has been hijacked by the tourist industry. They're not allowing the fisher folk to rebuild, but they're allowing the hotels back. And, to some small extent, there's 4 or 5 papers. To some small extent, we as ecologists are complicit in that. Alex and I have been doing our best to knock these papers down one by one. But, we haven't managed to, I'm not sure that we have as yet managed to affect policy. One of the ways that I've tried to affect policy is expanding my range of areas that I publish. And so this is an opinion piece that I wrote for the New York Times. It was published on the 2nd anniversary of the tsunami. Julian Cribb, Sean, Catherine and Terry also helped me put this article together. But so in this article, False Hopes and Natural Disasters, I make all these points. The main reason to put it up is this fantastic piece of artwork by the artist at the New York Times, bags of money being thrown at this tiny little natural barrier and this awesome tsunami. And I think, what it sums up is that the energy that's involved in one of these events is astronomical. Trees and natural barriers, it's indifferent to natural barriers. So anyway, a couple of lessons. Don't restore reefs. In this particular example, it's unnecessary. And the recovery that we've seen at some of these sites is astronomical. One of my sites in the front of Lochner, I've had a 10-fold increase in abundance in the 2 years since the tsunami. That reef's been dead for 20 years. It's slowly coming back. Take humans out of the equation and reefs come back. And so clearly it's managing human impact that's the secret to success. Things like restoring reefs, particularly on a small scale, is just not worth the effort. And again, if you're serious about saving lives, revegetation is not the way to go. Early warning, education, planning, that'll do it. Thank you.